Hey, and welcome to, what do we want to call this? We're going to call this vRealize Operations 101, Aria Operations 101, whatever way you want to think about it or look at it. But what we're going to be doing here is what I like to call Christopher's favorite things. That's kind of the important part of it. You know, my name is CXI. I'm Christopher here to talk to you about these things, and welcome to the channel. Welcome to the Forgotten Manual. WTF, man, the tech edition. So today we're going to get started on vRealize Operations and what I feel like everyone should be doing as table stakes. And the areas we're going to jump into and focus on are going to be in the areas of right sizing. I love me some right sizing. Reclamation. I also love me some reclamation. Generically assessing capacity. That is an important area in the world of things as well. Automation Central. We're going to focus on just those 4 items. There are so many other things we can do. However, I'm just going to look at those 4 because those 4 are powerful enough on their own. So we're going to start with assess capacity. That's kind of the key. So jumping on into assess capacity. And what we're going to find is we get data about our clusters. Whether you've got 1 or more, it's going to show up inside this list here. And it's going to have various forms of not optimized, optimized, or an unknown state. And you might say, oh, this says optimized, so that must mean it's good. And the answer to that is no, absolutely not. Just because it says optimized, yeah, there we go. There, just because it says optimized doesn't necessarily mean that it is good. It's better than not optimized, but it doesn't mean, oh, you can ignore that. Don't even bother looking at that. And I'll give you an example. Well, we'll dive into something that's dark, something that's red, something that's ugly. So we'll go let's grab this production data center. And it's going to immediately give us an output of data. And what's nice about this, and let's see, let's go find some arrows. What's nice about this is it's going to tell us what the bad things are. So the key things here is I've got 4 clusters in here that are at critical level. I've got a total of 5 clusters, right? But I've got 4 that are critical level. You know, and they're critical in the forms of CPU and memory, at least this specific cluster in question. You know, as we look at the other ones, I've got 0 days remaining on that production one, 61 remaining, and that one actually is not doing nearly as good. So we're going to go and dig a little deeper into those ones. Because as we can clearly see here, we have 0 days until we run out of CPU, and that's just the truth, right? The same is true for memory, right? In this particular cluster, we are out of CPU and memory. Like this, production south is being hit hard. I look over at production west, and I get a different picture as it relates specifically to production west. Same, oh, CPU, wow, look at this. It has shot up, we brought it down, and then it shot back up again. This is a perfect example of we fixed it, but we didn't actually finally fix it, right? We did the best we could for the time that we had, and then obviously demand called for things to go up. But then our memory allocation also went up, and our memory demand also went up. And we'll also take a look at production north, just as, you know, a sample out there. Same kind of thing, CPU was fixed and then shot back up again. Memory allocated was fixed and then shot back up again. And the same is true for memory demand. Memory demand, though, has got a little space, but not entirely as much, right? We've got 119 days as opposed to a 63 there and a 61 there. So it gives you a good sense of the health of it. Whereas if we pop down, look at Production Central, Production Central is pretty healthy, right? You know, it's got its ups and downs. I imagine this was probably when they took some nodes out of the cluster, then added more nodes back in. Same kind of true from a memory demand standpoint, and even disk space. You know, we're not even digging into disk space at the moment, but that's fun stuff. I will say, if you look over here, what we're doing is we're looking at the last 12 months of history, and we're predicting and forecasting for the next 12 months. And that is what this tool will do for us. If we wanted to, we could, you know, narrow that down like, oh, I just want to look at 6 months. Or I just want to look at like the last few months because we drastically changed the environment. Whatever, you know, go whichever path you want. But when things show as 0, or things show as red, that's a problem, right? Even like, look at this, we're only looking about 3 months back. It's like, it's been bad for the past 3 months. You know, has it been better for the past 6 months? We're gonna find out. It was actually okay up until, what is that, November 8th. And then things started going much further south. So where we take on this is we now have a gauge of, we've got problems we need to do something about, right? We have, as we originally stated, we have assessed the capacity. So what can we do about that? So the first thing I would do in this scenario is I would try to right size. So I pop over here into right size right off that main page. It left us on production. That's where we were. Okay, this one's not a good example because I don't have anything I can reclaim. We're just an overrun cluster. So we're going to pop over to a different, we'll call it janky cluster. Here we go. This one's a perfect example here, SC2DC01. Let me go grab my little drawy things again. Okay, what we can see here is we have oversized VMs. Hey, we've identified that you have 81 VMs that are oversized, and we should really reclaim 127 vCPUs and 232 gig of RAM. That's what it's recommending out there. And I'll know some of you out there like, I can't trust your recommendation engine. I will say, as one of VMware's largest customer and user of this technology, there was a time I didn't trust it. I'd be like, oh, how can I trust you to determine whether an item should be, you know, resized down? And I got to that point of, yeah, no, I'm good with you. You know, when you're running tens of thousands, hundreds of thousands of data centers, you might reach that point to say, or one data center. You might reach that point to say, you know what, it does a really good job in its recommendations. Let's just accept them, you know. And so we'll go expand out some of these items in here, and it's to say, hey, look at this one. I've got this SC2 VESXi 37 one. It's allocated 4 vCPUs. It recommends we reduce by 2 vCPUs. Now I will point out this part, recommended CPU reduction, because sometimes people might look at this and say, okay, it says I've got 2 vCPU in Skyline, and it says I should reduce it to 0. And it's like, no, no, no. You should reduce it by 0. That's kind of the catch on this. The same is true over here. Hey, I've got 8 gig allocated. We recommend you reduce it by 2 gig, which is to say to drop it from 8 down to 6. And I point this out because sometimes people might be concerned about this. It's like, now, these ones are easy. Hey, 4 reduced by 2 equals 2. That's easy math. But when I've got 3 reduced by 1, like, I'm not going to take it from 3 CPU down to 1 CPU. And I'm like, no. I want you to reduce it by 1 CPU. And I want to point that out because, well, it comes up enough that I like to point it out. So this is the harder side sometimes. This is a real scenario I've run into numerous times. Hey, I need to reduce the amount of CPUs you have inside this host. And like, the app owner's like, I can't reduce that CPU count. I can't bring that host down. It needs to be on always, right? That is what they're going to say. So don't fight the hard battles in oversized VMs, oversized CPU and memory. Even though we know we need to reclaim that CPU and memory because our cluster is overrun at this point. Instead, let's focus on undersized VMs. Undersized VMs tends to be a little easier pill to swallow. So in these scenarios, let's find, here we go. App A DB Tier 1 Node 1. Today it has 2 vCPUs. It recommends that we increase it by an additional 2 CPUs. And we can ignore the memory part. So if you have CPU hot add or memory hot add, or you have an operating system that supports CPU hot add, memory hot add, because that's important, then if it's already enabled, you can just go and add those additional resources and the team can feel good. However, if you don't have it, or you want to use it as a way to just talk to that app team to say, hey, I'm not trying to take your resources back, okay? Just hear me out. I'm not trying to take back resources. We've identified, your DB tier over here. It needs some additional CPUs, but I need to bring it down to add that. Like, when can I do that? And I will tell you, I had production environments that could never go down for a second. They're like, yeah, take it down right now. I'm like, it's 2 p.m. on a Tuesday. And they're like, yeah, now is the time. You're giving me stuff? You can absolutely take that thing down to give me resources. And in our case, we didn't have hot add enabled, which justified the need to take that resource down. But that helped build trust with those app owners, with those other business units, to where, since I'm giving them stuff, they felt a lot better about me starting to reclaim those resources as well. You know, we're going to go, this one has no CPUs to add, but it does have memory to add. So we're going to take a look at some of those examples. And it's just like, hey, add an extra 3 here, and add an extra 2, add an extra 1, right? It's not too crazy as far as the number of, you know, additional memory we want to add to these particular nodes. But the point is, if it's going to make a recommendation, hey, you should add these additional resources, it's because it's going to make that asset perform better when it's undersized. And the same is true when it happens to be oversized. Hey, it's got too much resources, it's going to cause performance problems. It can cause performance problems. It can overrun your cluster, but it also is something that's going to benefit the cluster and that node in general. Hey, you've got too much. You don't need to be having all that much. And that's going to immediately make our life better in our cluster management and our operational management. Now the catch is on this, hey, I need to go resize that thing. Back in the old days, I would go and I'd open up the VM and I'd go inside of it and open up inside of vCenter and I shut the node down. I go to those resources and I change them or what have you. Like that was always the process. But these days, I can go check that box and hit resize. I can go resize that VM right now. Or I'm going to jump straight into Automation Central for a moment here. I could go into Automation Central, which I'm actually going to do from a different screen. I can jump right into Automation Central and I can create jobs that are going to go in, resize those VMs. So I could say, hey, I want you to right size my my oversized VMs, you know, downsize, oversized VM. I want you to go, let's call this right size, right? I want you to go right size my oversized VM. I understand, I check the box. And I want to apply this to a specific cluster. We'll go grab like this HCX cluster because it's all based upon scope. And I'd say, hey, I want you to go right size those oversized VMs. However, if the object name contains template, I don't want you to apply this to that. I want to filter out those items. And then I can say, all right, I want you to do this. Let's do this every week on maybe Sundays at, you know, something like 11, no, not 11, like 3 a.m. And I can go and kick off this job here. Let me go get rid of that Tuesday. What? Why does it not like that? What are you giving me? Is it because it occurs in the past? Yeah, I know. Because I specified the start date. This is a good error to be getting there. So I'm going to go and specify in the present future. There we go. That's a bug that you would encounter, right? Not a bug. Actually, that's by design. So I say, hey, starting this upcoming Sunday at 3 a.m., I want you to go and right size this thing with no end date, and I want you to send me an email or what have you. And it'll go and do that, and it'll start to right size those things, and life goes on. The same can be from upsizing assets. And then you'll start to get a little history report that's going to show you, hey, we went through and reclaimed this stuff. And you get this little pretty picture looking back in time like, oh, wow. You know, our cluster reclaimed 5.2 terabytes of storage. And, you know, what did we do from right sizing? Because we're really focused on right sizing there. All right, I haven't actually right sized anything in here in a while. So the point is you'll be able to do that. So let's now, since it brought it up, let's talk about reclaiming. Right? We got into, we can automate right sizing and we can take things up and take things down. But the last item on our journey we wanted to talk about was reclaiming. So we're going to hop over here into reclaim right off of this little optimized capacity pillar. All right, well, we're going to go click on our all DCs when we have over here and see what we can reclaim, because reclamation is key. Now, let me go find my little arrow again. I'll point out here what's nice about this is it's going to say, hey, we've got 233 VMs we can reclaim and 328 orphan disks to reclaim. And we're going to go and revisit what that means here in detail. But also, it's got this breakout of reclaimable capacity. 213 vCPUs, we'll call it 400 gig of memory, and about 10 terabytes of disk space. Now, we're going to talk through some of these elements a little bit, right? So the first part is, right now we're on a thing called powered off VMs. Do you know what a powered off VM is? It is a VM that has been powered off. Whether it's been powered off for 0 days, or it's been powered off for 145 days, or it's been powered off for, what do we got out here? 265 days. And as you look at your virtual machines, I've talked with people who say, yeah, I've got a script that goes and cleans these things up. And if you say you've got a script that cleans them up, and we see stuff that's out here for, you know, hundreds of days, I will have to ask, do you? Do you really have a script that goes and cleans that stuff up? And there's no judgment there. I don't care whether you do or you don't. I care that you are aware of, hey, I've got all these VMs that I powered off 145 days ago. Do you still need those VMs? And if the answer is no, then we should delete those VMs. All right, so the next item I'm going to jump in here is snapshots, right? Snapshots absolutely have their place. A snapshot that I took for the purpose of a backup or what have you, and then I was going to, clear it out. How long should a snapshot live? Maybe not 650 days worth. Maybe not 348 days worth, right? Maybe not 510 days worth. How long a snapshot should live is entirely up to you. However, I raised the question of if you have snapshots out there like, yeah, I took that for this reason, and you meant to clean it up later and you didn't clean it up later, this is a great opportunity to, hey, I'm aware of this now. I want to go check this box. I can go delete that snapshot right from here. Or I can go schedule that action, right? I don't care what you do with your snapshots that are hundreds of days old. Just the same as I don't care what you do with your powered off VMs that are hundreds of days old. I care that you know about it. Hey, I've got a policy around this. I go and clean this up. Awesome. Go clean it up. Do what you're going to do. It's up to you. That is the best part about this. Now, the next time I want to jump in here is a thing called orphaned disks. Orphan disks is very fun. I usually like to find whichever is the biggest on my list here, right? I'm going to go find, there's nothing too big in here. I mean, I'll take like something for 175 gig, for example. So what an orphan disk is, when you delete a virtual machine and you don't remove the virtual machine from disk. And you might be saying, yeah, but inside of vCenter today, if I go to delete the virtual machine, it automatically deletes the stuff from disk. And absolutely, I agree with you. That is true. However, many versions ago, let's say versions from 1400 to 2000 days ago, or even 500 to 2000 days ago, there was a checkbox when you would be deleting that virtual machine that says, do you want to remove from disk? And sometimes people are like, you know what? We're gonna check or uncheck, whatever it was, I don't know. We're gonna go and select that thing. We're not gonna remove it from disk, and we're gonna go back and clean it up later. I've been down that road. I know that road very well. 100% I support. That is a thing we did between 500 and 2000 days ago. So you go and you do that, and then I'll tell you, when's later? Later's now, right? Later is here now. Did you go and clean it up? And the answer is you did not. No one cleaned it up. 99% of environments I've ever looked at, I find orphan disks that typically are, 300 to 2000 days old, and sometimes more. But the point is, now you know. You cannot automatically delete orphan disks inside of VROPs. So that is not a thing you can do automatically. It requires you to go and perform a process, right? You have to go and find that particular disk. Hey, let's go look at that disk. We're going to make sure, and then we're going to delete it, right? If I hover over it there, we get the full path. Because that could be a catastrophic event, if it is legitimately somehow being used. It's not, because the last modification date is thousands of days old, but sometimes people have a policy that says, you know what, we need to go and review these things, and we will not automatically purge those items. So that becomes a homework assignment for you to go and clean up those orphan disks. I say that because it's 100% true, and it's something you're going to need to do, which I encourage you. Delete those powered off VMs that you don't need that are hundreds of days old, right? Delete those snapshots that are not needed. If it's a template, it's a golden image, it's a VDI, blah, blah, any of those things, okay, go take that one, exclude that VM, right? But if it's not those things, it's a snapshot that's 600 days old, for whatever the reason is, go clean that thing up if you don't need it. Go through your process to clean up your orphan disks. And then the last item on here, idle VMs. An idle VM is defined as a virtual machine that is using less than 100 megahertz over like a 30-day span. And even further than that. Because if you go back and you look at the details on some of these, which I'll show you, I'll go grab an arbitrary VM in here. So it's got this one right now. It's got 4 vCPU and 16 gig RAM, right? And we're going to go, it's got 4 CPUs, so we're going to go pop into this little one called share. I'm going to go open up share, and I'm going to go pull up my metrics. I mean, it's got all this lovely data there, but I'm going to go pull up my metrics, and I'm going to go and search for CPU, right? We're going to go search for CPU, and we're going to find our CPU demand, CPU usage percent. Actually, we don't want usage percent. We want the actual megahertz used. We don't want percentages around these things. We want the demand megahertz is what we want. And as I look at this, and now I'm going to go expand the date frame in here. Let's go look at like the last 90 days for this. Let's do that. So as I look at this thing, I've got a low of, the low has been 13 megahertz. The high has been 47 megahertz. So this, and that is not percentage, that is all in megahertz. So if I'm using less than 100 megahertz out of a CPU that's got like, 2 gigahertz roughly, right? If I'm using less than 100 megahertz, I don't need 4 vCPUs attached to this particular thing. So I would then encourage, hey, let's right size this share here. So we're going to pop back over into our reclaim that we just were. I'm going to go a little deeper on what that means. Now this thing will say, hey, you should delete that VM, right? You should power off and delete that VM because it's no longer being used, right? It's because it's an idle VM. Now there's share, right? But Christopher doesn't believe in the powering off and deletion of idle VMs without heavy, review. And the reason for that is, I'm going to give you an example of 5 idle VMs. 1, share, right there. I mean, there's an example right there on the screen. Hey, share is barely doing anything. Yep. We should delete it. Nope. Why? It's a share. It's doing something. It just doesn't use a lot of resources to do it. So I can reclaim CPU and memory from it, but I don't need to reclaim the asset itself. Some other examples are TFTP server. Hey, that box doesn't do anything. Ever. Ever? How about once a week when it's taking backups from your switches and routers and your call manager? Oh yeah, it does that. Okay, we can't be doing that. Maybe we can downsize it, but we can't eliminate it. In the same breath, SFTP server. That doesn't do anything except for when I need to SFTP something. So it does nothing except for a very essential asset when you need to do it. And like the last in that line is jump box. A jump box is never used ever except for when it's used and it's absolutely essential. So that's why I can't holistically advise the powering off and deletion of idle VMs, but I fully support the downsizing of those. And if it says it's an idle VM and it has more than 1 CPU, drop that thing down to 1 CPU. Memory, go take a look at how it's being used in memory, but drop that thing down to 1 CPU because it's using less than 100 megahertz, therefore it only needs 1 CPU. Now, I will put an extra conditional on there. Hey, I've got this Nessus box or something like that, some type of active security scanner. Yeah, leave that box as it is because when you actually use that thing, it's going to use every CPU you throw at it, so I can justify that having additional CPUs. But 99% of the rest of the workloads, no, not necessarily. If it hasn't used more than 1 CPU in the past 90 days, or if it hasn't used more than 100 megahertz in the past 90 days, you can downsize that thing very comfortably. But feel free to look at your stuff, your use cases and everything. Sometimes you may have a vendor requirement that may be irrational, but you may have a vendor requirement. So you go with what makes sense. However, I'm going to be willing to say 99% of your oversized VMs are not operating within some vendor requirement, especially if they're 99% of those oversized VMs are also idle VMs that are doing less than 100 megahertz holistically throughout their entire lifetime. So that is, let's pop back over to the top here. That is the little journey that we have now taken on the worlds of right sizing. Hey, right sizing, there it is. Reclamation, how to assess that stuff, and even how to automate those items using Automation Central. We are just scratching the surface of what you can do within the Aria Operations and vRealize Operations suite. But I encourage, if you haven't looked at these items and spent time focused on them, everything else will be valuable, but this is where you're going to get your biggest bang for your buck immediately and out the gate. So I hope you guys enjoyed this. Look forward to the next one where we go a little deeper into more of the things we can do in here as we move on to 201 and 301 type lessons. All right, I hope you guys enjoyed. And be sure to like and subscribe the video. That really helps the channel be successful. So if you enjoyed this, or even if you didn't, definitely give us a like and a subscribe. Thanks.